Wes, Wes is a unique guy. I need to like pause for a moment here. He's somebody that I've known for a few years, just from having met, probably just at Web Unleashed events. But there are few people that I've met that are more generous with their time, with their knowledge. He's been a web development teacher, a course creator, a co-host of the Syntax podcast. His love for open source software and community learning is legendary. Spending time on GitHub, Twitter, IRC, connecting with other developers, creating courses, doing events like these. There are not that many people in the industry that are more generous with their time. I'm so pleased to welcome you again here, Wes. Thank you for joining us. I really can't wait to hear what you've got to say this time.
Awesome. Thank you so much. I appreciate it. All right. Wow. It's just me now. Hey, everybody. Thanks so much for coming on out to the talk. Really excited for that. My name is Wes Bos. I'm from Hamilton, Ontario, just down the road. I was really hoping this year we'd be back in Toronto having beers with everyone, but fingers crossed we get that next year. I'm at Wes Bos on Twitter, TikTok, Instagram, all those things. I won't bore you too much. You can find out more about me online there. I have a podcast called Syntax FM. We have 3 shows per week. Pretty fun. If you are interested in learning more about web development, and you like the sort of energy, tone, and whatnot that we give, then check it on out. So today's talk is on TypeScript, and sort of just a introduction, sort of a high level. What is it? Why would you even want to use it? What are the benefits of it? How do you get started and use it? Not too much of an in-depth deep dive. I'm working on a course right now on TypeScript that is going to go all into it. But these are just kind of like 4 or 5 different things about TypeScript that I think you, the watcher, should know. So what is TypeScript is sort of the first one. It's TypeScript is JavaScript with a type system added on top. And I'm kind of glad we had the talk before this one, because it sort of talked a little bit about all the benefits with that type of stuff. It's not really a new language. So first thing when I heard about TypeScript is like, okay, that's one of those like somebody built another language that I have to learn. It's kind of like CoffeeScript and it compiles to JavaScript, or PureScript. You have all these like, oh my gosh, another one that compiles. I just want to regular ass JavaScript, right? And it's not really that. It's just you bring along all of JavaScript, and then you add on some descriptions on top of the regular JavaScript that describes what your data looks like. They really should have just called it descriptive JavaScript or descriptive script, because that's exactly what it does. So let's talk about what types are in the first place. Types describe the type of data in your application. And I sort of laughed after I wrote the sentence, because I just used the description in the word that it actually is. So let's take a look at some examples. And these are code examples here that are very explicit. We'll talk about implicit and generally something this simple, you're not actually going to type it out. We'll talk about that in a second, but just humor me. If you know a little bit of TypeScript, don't start screenshotting and stuff like that. Essentially, you've got types in JavaScript, and when you create them, you tell the compiler what type it will be. So you create a string, you tell it it's going to be a string. You create a number, you tell it it's a number. You create a Boolean, you tell it as a Boolean. You can get a little bit more complex, and you can have arrays of things or collections of things. It's not really all that complex, but you can tell TypeScript, okay, I'm expecting this to be an array of strings instead of just a regular string. And then you can get into creating custom types, which is probably most of what JavaScript is well, you got a person, that person has a name, and their name is a string. They have an age, that's a number, and if they're cool, that's a Boolean, right? And then what happens is when you go and create something that matches up to that type, when you define your type, you simply you add this little part. This is the little description part that I was talking about, right? So colon person is say, I'm creating a variable called Wes, and it is a person type. And that person type has all of the properties that we described in the type earlier. And the values all line up with the types that we defined earlier, right? Uh, Types also come. Somebody said one of the statements is not true. It's age. It definitely age. Okay. Where were we here? So types also come along depending on your environment or libraries that you're working with. So if you're working in the browser, you can often have all the browser things. If you're working in Node.js, you can have types for all the built-in Node.js stuff. So here I have a video. It is a type of HTML video element or null. We'll talk about that in a bit. Don't worry too much about that. A stream is a media stream, and those types are much more complex than string or number, but they are types of data that you work with in the browser. It's either a video element or a media stream that's coming hot off your webcam. We can also start to type functions, both the type of data that a function takes in and the type of data that a function returns. And that's super, super helpful when you are running a function because you know exactly, all right, what does it need? Okay, here. And what does it need back? What am I going to get back from them? Okay, I understand that. So one function that I always type out when I'm trying to teach people is calculate bill. Calculate bill takes in a number and a tip. And then we'll add those two things together. You see here, we are typing the fact that it expects to take in a total type of number, a tip type of number, and will return a string. And then inside of here, we tally them up. That's a number. We stick the tally into a sentence, which is a string, and then we return the sentence, right? So we're saying it returns a string. We're returning a string right there. Here's another example is if you make a function that needs to take in a person, you can obviously, the argument is person with a type of person, right? Remember earlier we had those three properties, then you can go ahead and use them all inside of there. But why? Like, why did I just do all that extra typing? The last talk we just said, like, doesn't that inhibit creatives? Like, oh, that seems like a lot of extra work. And like, I want to spend my time making cool stuff, not adding all this extra stuff. Like, of course it's a number, Wes. I can see that it's a number. So let's go into some of the benefits that you get with TypeScript. So in my opinion, there's kind of like two camps or areas that then the benefits fall into. The first one is code authoring. You, the dev, DX is what we like to call it a lot now, developer experience. Basically, it makes it more fun, more enjoyable to actually write code that is in TypeScript. That one's up for debate, obviously. In the last talk, we had that. And a more resilient code base, less bugs that you're going to get when you write all of your code in TypeScript, because sometimes it is not always fun writing stuff or trying to figure out bugs in TypeScript. But the reason we do that is because your code base is a little bit more or much more resilient. So let's look at some real world examples as to what those look like. First one, amazing autocomplete and developer productivity is the first benefit. We have here a person I've created, Wes, and now I'm going to go ahead and start to access the properties that are on Wes. What happens is, in this screenshot that I have right here, I'm hovering over top of Wes with my cursor. And what pops up in your editor, VS Code, WebStorm, whatever it is you're using, it's going to immediately provide you with information about the type of that variable. So if you're in another file, you're inside of a function somewhere else, and you have a piece of data, you go, what is this data? Is this a person, or is it some other type that we might have had? And to us, we know immediately, okay, it's a person type. So okay, at least I know what it is. Then when you start to access properties and methods that are inside of it, you immediately know what the properties are. Name, age, cool. I added another method there called sup, just so I could show that it pops up. And that is so handy because you don't have to like go back to where it was defined or where it is, or console log the object and open it up and say, all right, well, what are the properties inside of this thing? It knows immediately what they are. Same thing with function arguments. If you are trying to use a function and you say, all right, well, what does this function take? Well, like if you're just writing JavaScript, your editor is going to tell you it takes an argument of person. But in TypeScript, it'll go one step further and actually tell you the type of argument that is needed. And if you don't give it the right, you see the red squiggle of death underneath here is I hadn't given it a person yet, so it squiggles it right underneath it. It says, hey, you didn't fill this thing out properly. Same thing with like built-in browser APIs. You don't have to always go to the documentation to figure out what all the properties and methods are on your APIs. Here, what I did is I just created a video element. Immediately, we know that it is an HTML video element. This is actually a good example of inferred types. We're going to go into that in just a second. But when I say video dot, immediately boom, pops up all the methods, all the properties that I can possibly have from that type. And I don't have to go looking up any of that data. Benefit number 2 is error detection. So how many times have you done this? This is my entire life is trying to figure out is it title or name? You know, like you create an object, you have your data on there, you go ahead and use that data and you go, it's not showing anything. And it's because you used the wrong property. So immediately right inside your editor, before you even have to go to the browser, it's going to tell you, hey, title is not a property that exists on a person type. And then if you mistype something, notoriously bad speller, it says, if it's close enough, it'll try to be like, hey, dummy, did you mean name and not nam? Same thing with when you are passing arguments to a function. TypeScript will sort of dump these. This is one tricky part of TypeScript that you have to get used to. And basically, you have to read through all these stacked errors in TypeScript. But if you kind of look at it here, it says property cool is missing in type name string. So here we have a generate person HTML function. Remember when we typed that earlier, we said it takes in a person. So I've passed it the data that I think it needs, a name and an age. But TypeScript already knows, hey, silly goose, you forgot one of the properties, and I'm going to yell at you immediately. It'll underline it right away. And then I also have these little red ones here. This is part of my editor. I think it's called like error lens, and it will take any errors that you have, TypeScript errors, ESLint errors, and it will just inline them right in it. So you can see the error as you're typing the code. One kind of cool thing is you can also get TypeScript to sort of scaffold out the properties that you're missing. So you are making a type. You go, okay, TypeScript, you're so smart. You know that I forgot these things. Why don't you just give me the types? Or why don't you just give me the properties? So what you can do is there's a quick fix in VS Code. All editors have this. You can add missing properties and it will go into the type and it'll say, all right, well, your object looks like this. The type requires these values, so just add them to your type, and then you can go ahead and fill them out. How are we doing for time here? 3:40. We're doing pretty good. Benefit number 3, library typing. So you're using a library in your code, and generally you have to go over to the docs and figure out what are the methods, what are the properties, what do functions need. You're using 3JS and you have to pass it an instance of a canvas or something like that. And you're like, does it need a canvas element or does it need a context element that's pulled from canvas, right? Like, better go fire up the docs. And, these docs are for the newest version. I'm on one version older and got to find the old docs for that. With libraries, if you go onto NPM and you look up a library, you're either going to see this beside the library name, TS, or you're going to see this DT. And what those mean are that the library ships with types available for all of the functions, all of the inputs, all of the outputs. Everything in that library is typed. And you can import the types and infer them from actually using it. If you see this one, DT, that means this library is not written in TypeScript. It doesn't ship with TypeScript, but there is a massive community effort to add types to libraries that don't have types. And what you have to do is you simply just install at types / the name of the package. And you will automatically, as long as your TypeScript tsconfig includes those, it will pull in those types and give you types. I feel like I'm saying types a lot. It will pull in the types for all your functions. So pretty simple things like this. This is date functions, a library that I have. And I use the add function a lot in date functions. And what you have to do is you pass it a date that you start with, and then you pass it like a config object of what do you want to add? Do you want to add 1 day and 3 hours? Well, you simply just open your bracket, open up your autocomplete, and it will show you exactly what properties are potentially allowed inside of that. You don't have to go to the docs and move through the docs. They're always a little bit different for every single one. You can get all that information right away, right inside of your editor. Number 4 is database typing. By the way, feel free to ask some questions in the Ask a Question section. I'll be answering it at the end here. So database typing. This is just one example. Prisma is an ORM, which is essentially just a software layer that sits on top of several different databases. And Prisma will generate all the types for everything that is in your schema. And that includes both the queries to query the data that you want, all the filters that you want to pass into a query, as well as all the data that comes back. So you can have all the amazing auto-completion typing that you are used to. Most database libraries out there will have some sort of TypeScript support so that you can get this really nice data. And again, you're not always hopping back into your schema or console logging an object to try to figure out what are the possible things on there. You can just start typing and you can see it in the dropdown. Another helpful thing is if you pass it something that is not allowed when you're creating, right? TypeScript is very strict. You can make it less strict, but that kind of defeats the purpose. So if you try to do something that is not allowed or does not fit into a specific type, then it's going to yell at you right away. You don't have to wait until, I don't know, maybe you have like an endpoint that only gets hit once every month because somebody runs a report and you accidentally spelled something wrong or whatever. You don't have to wait for that thing to fall over to figure out, oops, I put an oops property in there. It'll immediately show you that you have that. Benefit number 5 is refactoring is an absolute breeze. So right here, one thing about TypeScript, there's this thing called the TypeScript language server, and they provide a handful of what are called refactoring commands, because the thing about TypeScript is TypeScript knows about your entire project. It knows where every single variable is. It knows what every single type is. It knows every single input and output and import and export to functions and variables. So what you can do is, because it knows so much about your project, is you can refactor it with a lot of the tools that you have. So here's just a really simple example is I have a statement inside of a template tag, extract it to its own variable and rename it right away, and boom, it's in its own variable. That's not that big of a deal, but there's others like, okay, I started writing this monster function in the wrong file. Now I want to move it to its own file. Like, how often have you done that and you've imported it into 16 different files around your project and you go, you know what? It's just not worth trying to move that because I don't feel good about where that thing is imported. Well, again, TypeScript knows about where everything is, so you could just move it to a new file. It will move the code for that function as well as any dependencies that it needs, things like imports from npm, and then it will update any imports that are throughout your entire application that are already using that. Same with like renaming a function. Like, I had a function in my code base for probably 4 or 5 years that was spelled wrong. And I didn't want to change it because I could do a find and replace, but like a find and replace is not the way to do refactoring, because a find and replace is just like a regex essentially. Whereas if your the TypeScript parser can actually parse your entire project, it knows that, okay, this is a function, this is where you're using it, this is where you're importing it. I can update all of those things for you. Benefit number 6, edge case detection. This is one thing that people, when you move to TypeScript, especially, there's a setting in TypeScript called strict, and you should probably turn that on when you're doing a project from scratch. Sometimes people turn it off when they're moving over large projects, but what happens is that you don't necessarily think, okay, well, I'm going to select the video on the page and then I'm going to play it, right? What's the big deal about that? Well, TypeScript knows, okay, there's a possibility here that it's probably an HTML5 video element, but, or null. There's a possibility that it couldn't find this on the page. And then the fact that you go ahead and try to play it on the next line, come on now, there's just a possibility that it wouldn't exist. And you, the developer, go, that's probably fine. But in reality, what you should be doing is you should be checking if that data is actually there. And there's a number of ways to do this in TypeScript. Generally, it's called type narrowing or type guards. And this is essentially just making sure that the data is good enough, or like actually looks like the data that you're expecting, before you go ahead and use it. So here we just say, if there's no video, throw an error, or if there's no video, then create one with the document.create element, or if there's no video, pop up something to the user. Like, you have to handle the actual error there. And that's a big part of TypeScript, is it forces you to go down every single one of those little edge cases and say, okay, there might be I might have a bit of a blind spot here, and you go ahead and catch all of those. All right, so those are like the benefits to me. Let's move into some important concept in TypeScript. There are 2 types in TypeScript that come default, and they are any and unknown. And the big, people always ask, like, what's the difference between the 2 of those? So any in TypeScript is that it's literally any type, meaning that this variable could be a string, could be a number, could be literally anything else. And then you have unknown, which is not the same as any, but it is, I don't know what the type is. So you're saying, okay, well, those kind of sound like the same thing. Well, if you try to call an any function, this is going to be allowed. Any value, parentheses. Is it a function? Is it a method? Who knows? It's anything. So it's probably fine. And it's not going to throw an error in that case. And because of that, generally using any, there are a couple of valid use cases for any. So it's not something like you should never use any. I hear people say that all the time. There's some use cases for it. But this is why you probably shouldn't use any. And then with an unknown value, it says object is a type of unknown. So if you don't know what it is, you can't start using it. You got to figure out what it is first. So what you have to do is you have to have what's called the type guard, where you say, all right, let me check if it's a function, and then you're allowed to go ahead and use it. And that's much preferable in TypeScript. If you literally don't know what is coming in, which sometimes is the case, I have like a debounce function that does that. Then you check where it is. Same thing with a number. Remember that any value, maybe it's a number. Let's try add a 1 to it. Well, the any is going to allow you to do that, whereas unknown, it's going to say, I'm not allowed because I don't know that it's a number. Again, you have to check if it is a number, then you have to go and use it. Alternatively, you can assert it or cast it, sometimes called as a number. It's generally better to check if it is a number and then go ahead and use it than to use the as function in TypeScript, because the as function in TypeScript is sort of saying, hey, TypeScript, I know better than you. It's a number. Okay. Got it? And sometimes you have to do that, but generally you have to say, hey, TypeScript, check if it's a number, then add 1 to it, instead of trust me. Because how often have you as a developer said, trust me? And it didn't pan out. Implicit versus explicit. This is something that I said earlier. Lots of things in TypeScript don't need to be typed. Go back to the first slide. The fact that I set that to be a string and a number, it doesn't need it. So here I have a variable called age. I've explicitly typed it as number. That means I explicitly put my keys on the keyboard and typed :number, and I set it. That's okay. But see, this is a little bit different. That means, in my editor at least, this means that it is implicit, meaning that it can tell by the type of value that I've assigned to it that it is a number, and you don't need to explicitly type it. Same thing, here's a function called make a sandwich, and we are explicitly typing it, saying it will return an object that has a type of sandwich. And then we go ahead and return an object that has all of the things that a sandwich needs: bread, a name, meat, an array of string toppings, right? And TypeScript is happy about this. I haven't typed this return value, but it says, all right, well, I know you're returning a type of sandwich, and the value that you're returning 100% overlaps with what a sandwich is. So good job. That's implicit. Implicit, okay, so when should you use one or another? Implicit is okay for private and local variables, meaning that you just have them inside of a function. If it can be implied, then do it. You don't have to explicitly type everything. It can be exhausting. It's good to let things be inferred when possible. Explicit is for function inputs and outputs. Input a name, output a sandwich. And explicit is good for anything that is exported or public. So you have a library, you have something that is exported from a module into another one, you should explicitly type those things where possible. 2 minutes left. We're doing good. Tooling. In tooling land, there's kind of like two things that need to happen. There's type checking, meaning that all those errors I just showed you, is type checking. And then the other side of it is compiling to JavaScript, which means that once your code is type safe, you just basically take all the TypeScript parts out and then just give you regular JavaScript that will run in the browser, because TypeScript doesn't run in the browser. JavaScript runs in the browser. So TSC, this is what comes with TypeScript. It does both of those things. TSC is what's running behind the scenes in your VS Code or your editor and giving you constant feedback of whether things are valid or not valid. And then once you're all done that, you can also compile it to JavaScript when you're done. Or if you're running a React app and you want to have instant updates in your browser, TSC will convert it from TypeScript to JavaScript so it can actually run in the browser. Then we have something called SWC. This does not do type checks, but it does compile to JavaScript. But it is Rust-based and fast as heck. So the downside to TSC is that it is kind of slow. And other tools that have come along, like SWC, and they are built in languages that are not JavaScript and are fast as heck. So generally, when you are running something in the browser, you use something like SWC or the next one, which is ESBuild, to do your instant live reloads, because they are fast as heck. And then to do your actual type checks, those happen via TSC. There is some mumblings whether the type checker will be either rewritten or something like ESBuild or SWC will also start to do type checks in the future. Then there's other tools, Vite. So Vite uses ESBuild that we just talked about. It does everything. It's like a dev server, live reloader, bundler, CSS handler, importer, frameworks, all of the things that you're used to. Vite is an amazing tool for that. Along the same lines, Parcel does similar. It uses SWC instead. It does everything exactly the same. It's just one tool. The days of crying over a Webpack are gone. You use Parcel or Vite, and it is up and running. Server side, let's talk about it. For Node, you use TSX or ts-node. Oh, I hear somebody. Am I getting kicked off? No, okay, sorry. These are to tools that either use ESBuild, TSC, or SWC to recompile it into JavaScript and rerun it as quickly as you can. Very good tools. There's also some new folks on the scene, which is kind of exciting, really. So like we've had Node as the only server-side JavaScript runtime environment, but in the last couple of years, we had Dino come on the scene, and that's really exciting. And Dino is built by the same guy who made Node, and it is first-class support for TypeScript, meaning that you can write your modules in TypeScript and just run Dino run. It has a web server built in. Really exciting, sort of coupled tightly around the Edge environment, and they are getting very close to having full parity for all the Node modules as well, which is kind of cool. Then we also have a new one called Bun, coming out of nowhere. Just last couple of months, you're hearing a ton about it, and again, it's really fast and it has support for TypeScript right out of the box, and it also does things like uses Node modules. So next probably 6 months or so, I think we're going to be hearing a lot about people saying like, I just took my Node app and now it runs in Dino or Bun very, very quickly, and I got all these benefits for little move over. That's kind of exciting, because like the last thing you want to have to do is like to have a whole TypeScript build environment before you actually get into Node, and these ones make it much simpler to write TypeScript for the server. So the question is like, do we even need TypeScript? Because there's another thing called JSDoc, where you can add types to your JavaScript without having to write TypeScript. You just write comments above it, and you get 90% of the benefits of TypeScript without having to actually convert your runtime or anything like that. You just write comments above it. Here I've said the type is a HTML5 video element or HTML video element, and I've got all of the same things that I did earlier. And this is an excellent opportunity if you are not able to move over to TypeScript, but you still want all the cool stuff that I was showing you. Same thing for functions. Here I've typed 2 params, a string and a number. You can also give them descriptions, which is the best. You can't do that in TypeScript. And then return the result. There's also, last talk is this, there's a proposal to add types to JavaScript. And the name of it confused the heck out of me at first, is types as comments. And what that means is that they are proposing that we write types pretty much the same as TypeScript, but part of the browser's job will to just to strip them. It doesn't run them, it doesn't check them, it doesn't compile them. It just says, oh, that's a type, throw it out. That's just part of the dev environment. I don't need it. That's kind of cool, because you'd be able to have types in JavaScript without having any build step or anything like that. So that is my high-level intro into TypeScript. Pretty exciting times right now. Pretty excited about TypeScript. And if we've got time, I'd love to take any questions that we have.
Oh, there are a bunch. Don't you worry about that.
All right.
So I want that was awesome. Thanks, Wes. So I'm trying to think of the best way to try and get to as many of these as possible. One thing that actually just bubbled up, and I want to get to this one actually now, because you were just talking about speed, TSC versus the other thing. Like, why do we care about speed if it's something that's really just being done on the dev side?
Yeah.
My sort of gut reaction was developer experience and build times and that sort of thing. But what's your take on those things, and where does the speed matter?
The speed matters when you make a change to your React application, you hit save, you move your eyes over to your application, that change is already there. So we can all remember back to the SaaS days when we had Compass installed, and sometimes you made a change and you sat there for 3 or 4 seconds while the whole thing regenerated and then updated the CSS. That's an awful developer experience. So the speed really matters in that. It does matter when you're building your JavaScript as well, because if you want to deploy an app to a server and have that thing live in 10 seconds, that matters. Whereas if your TSC is pretty fast, but the larger the project gets, we definitely have to be thinking about speed. So that's why those tools have been made.
Got it. And you sort of touched on this, but Don was asking, what are the actual use cases for using any type? Off the top of your head, can you think of any? Any?
Can you think of any? So I had a not a debounce function. I had a function that took in a event delegation. That's what it was. So I had an event delegation function that took in one of the arguments was a function. So a type can be a function, and that function argument could have any types of parameters in it. Kind of obtuse, but if you're saying, give me a function that has any amount of arguments and the type of them can be any, and you simply are just taking them in and passing them along to the delegated function. That was the one use case that I had run into. The other one is if you're converting a large code base over to TypeScript, there's going to be some time in between where you just have to slap an any on something and say, we don't have types for that yet. So we slap an any on it. And then what you can do is once you're feeling comfortable and you have some types in your code base, you can go turn off the, or you can search through it or turn off any rules that say no any. And then you can go start going through them and say, okay, now let's work on those any.
Sorry, I got distracted by Leo gnawing on the wall. He's a puppy. He just does that. So this next question is one that's really kind of dear to my heart. From listening to you on podcasts and talks and everything, it's clear you're a constant learner. How do you balance breadth and depth when you are making courses, conference talks, or just working on a project? I mean, how do you kind of navigate that?
People ask me that a lot. I'm pretty narrow in what I want. I'm a full stack JavaScript developer. I don't know any Rust. I don't know any Laravel. And yeah, I know a lot of things, but I am a pretty good JavaScript developer. So the things that sort of surround that, I'm able to pick up fairly quickly. And that's just a matter of I've done it for a long time, and I feel like I know JavaScript pretty well. So it might seem like I know a lot, but I don't know 3JS, it's pretty narrow. And I talk about the stuff that I'm interested in, the stuff that I know.
So now that you're obviously pretty familiar with TypeScript, is it something where that's your go-to? You just always write your JavaScript that way? Hamid was asking, if it's worth the time to use it for small projects. I know what my take would be on that. I think once you get used to something, you should just go with it, and it enforces good practice. But what's your sense of it?
I'm not of the 100% all the time, because sometimes you just want to slap something together quick and dirty, and you don't necessarily want to either go through the setup. That's getting a lot easier. The setup is because of tools like Vite, but still sometimes you got to put a tsconfig in there and add the things. And I literally just want to start and have this thing running in 10 seconds. And then also one of the comments we have here is that VS Code already does a lot of the autocomplete for you without using TypeScript. And that's because VS Code actually runs a TypeScript server on your JavaScript, and it does a pretty good job at doing the autocomplete. It's not nearly as all the benefits that we talked about today, and it's not all 100% good, because if you're creating a variable that gets passed into a function, it doesn't know that you're going to do that, so it can't infer the type from that. So I would say I reach for TypeScript on anything that will live longer than a day or two. And then for quick and dirty scripts, I still regular JavaScript, no problem.
Eric, that's Leo, by the way. And yes, he is really fuzzy. I love that. I love that time span. Like, unless you were literally throwing this out tomorrow, write your code so that you come back to it. Because honestly, like, look, who among us is actually going to remember that much about the code we wrote today in 2 days? Like, we just have like so much stuff going on, so many things to worry about. Yeah, if you don't clean up after yourself along the way, then you're going to get lost. So, I mean, there were a bunch of questions about code editors and autocorrect and autocomplete and all that sort of thing. Just sort of generally, are there any editors that you have not had good luck with? I mean, like GitHub Copilot was actually one that somebody had mentioned. What are some editors that are struggling, if there are any?
That it depends on like what you're working with. Like, there's a new editor out from the folks that make WebStorm. I think it's called Fleet or something like that, and TypeScript does work in it. But then if you want TypeScript in a Svelte project, oh, that's not supported just yet, and like I think like the two really good ones are, or maybe the three really good ones are, like the WebStorm or the IntelliJ based editors. Fantastic. Obviously, VS Code is probably the best one, I'm gonna say, because it's made by Microsoft. And then like Vim has a fantastic support for it as well. But like, then you're an obnoxious person that uses Vim. Yeah.
Oh, I don't know that he'd be listening into this, but shout out to my old colleague Benji, who was just a wizard with Vim. Probably been using it since version 1. If I can, it wouldn't surprise me one bit. That's amazing. Wes, I know that we're sort of running down to the end of the time. It's been kind of an incredible day so far. What's the next thing past TypeScript right now? Do you think that this is the kind of thing that will sort of filter its way into JavaScript in one way or another, so that this will just be vanilla at some point?
I think so. I think in the same way that jQuery became part of JavaScript, in that we got awesome DOM APIs. Will we? Or do I want it? Yes. Will it happen? Maybe, because the proposal is a very nice way to go about it. Types as comments, meaning it's a comment. It's not literally and like a /*. It looks like TypeScript. That's why I got confused about it. But it's nice because the browsers don't have to add type parsers or error handling or anything like that. It's simply just the browsers have to know how to throw it out so that they can run the JavaScript. So I think so, but we'll see. I've certainly been wrong many times.
Well, I think that was the one thing that was sort of going through my mind. So, if you think back to where we were 12, 13 years ago, when it was going from, are we going to have, it was HTML4, XHTML, or are we going to get XHTML2, and then HTML5 came along and sort of threw some of that clean up after yourself out the window. It actually relaxed a lot of the parsing rules and stuff, and it did that, I think, for pretty good reasons for the most part, in as far as the way HTML has to behave. But I don't know if JavaScript can really work the same way, because you kind of have to have all of it. It doesn't work when you only get half the JavaScript.
Yeah, that's a good question. I think it will be a lot like how we moved over to ES6, where like we literally changed the language. We added arrow functions and all this fun stuff, and that did break JavaScript. But for a certain amount of time, 6-7 years, you got to compile your JavaScript manually or as part of a build step, and eventually we'll be able to just ship types directly to the browser, and the browser will know how to strip them out for us.
Cool. Well, I think that is kind of wrapping us up for the day. Wes, as usual, mind expanding, even for somebody who doesn't write JavaScript. It really is fantastic. Always learned so much. Can't thank you enough for coming and sharing with us.